Hi, I'm Jill Tyler. Let's get started. So this is Real World Science with WEDO 2.0 and FLL Junior. I hope you like the introduction. I'm a digital integration facilitator for Moore County Schools, and I've been teaching for 20 years for the state of North Carolina. I'm a mother of twins. If you want to see the whole video of the jump, you can go to bit.ly/diffjill and see my skydiving jump with the Golden Knights. It was awesome. My daughters got to be there as well. I was nominated by a parent of one of my schools who works for the Army. How can Legos be used in science? So let's look at some of these real world challenges today. I want to start by telling you how we got it funded, and I'll share some resources. But this lovely lady in the picture here is Heather Bridges. She is the media specialist here at West End Elementary. She and I wrote a grant to the Moore County Public Ed Foundation and got our first grant fulfilled to the library STEM stations, and we called it the Libratory. And then another year, we did another grant for FLL Junior, which we started at West End and started with second grade. The next year, we just did funding through the school, and we did third grade. Or I did this one on my own at McDeeds Creek. Heather Bridges and I took a group of the students, kindergarten through fifth graders from West End Elementary, to present at NC TIES, the North Carolina Technology Conference. And this was us, and the students designed their t-shirts, and you can see the WEDO kit here, and we had students who shared that as well. So this is showing how it aligns with the digital learning competency alignment and digital content and instruction. So the digital technology enriched learning experience that encourage all students to pursue their individual interests, preferences, and differences. It also identifies and it helps them evaluate and utilize appropriate digital tools and resources to challenge students to create, think critically, solve problems, establish reliability, communicate their ideas, and collaborate effectively, the 4 C's. Immerse students in exploring relevant issues and analyze authentic problems through digital tools and resources. The software. I want to start with the software. So there's 2 ways you can use the software download. You have your Chromebook, so you can go to the Chrome Web Store and type in WEDO 2.0, and it's a Chrome web app that will be added to their Chrome apps. You could also go on the iPad to the App Store and search Lego WEDO 2.0 and grant all the access permissions. Make sure you do that as well. Same thing as it installs on the WEDO for your Chromebook, you want to grant all access permissions. Okay, so then on the home screen, you'll start here, and you click on the book to start your new code. And then from there, there's actually, if you click on the books, it will show the lessons. You can also, there's some documentation tools at the top. You can document by the students clicking on the camera to take a photo. They can click on video and do a video showing their work. They can type in different colors of ink, a few different fonts, and select different scrapbooking kind of pages where they can upload pictures, video, and respond in their journal. So it's like a little digital science journal within the WEDO software. Here's some national alignment, but it aligns very well with 2nd through 5th grade. I've even brought it down to kindergarten and first. They might need to make it a little more easier, or pull the Legos out for them and put them in bags, just because they make a mess of the kits. And the kits can be time consuming to sort, but it definitely aligns with space exploration. We've used it with pulling and pushing and moving materials, frog metamorphosis, the hazard alarm, and I even tied it with current events. We'll move on. Here's some 4th grade alignment, preventing flooding, predator and prey, sorting with recycling during Earth Day. 5th grade was speeding and moving materials, robust structures and testing different builds, animal communication, extreme habitats. But you have your guided builds and you have your open builds. Open builds are definitely using the full engineering process. But even with the guided builds, once they've designed a step-by-step guided build, you could ask them ways they would improve it, or adding embellishments, or make it better. Because I tell the students all the time, I can't think of any invention that hasn't been improved over time. And I always give them that challenge. I encourage you to join the Facebook group. There is a Facebook group for WEDO 2.0. You can get a lot of inspiration. Same thing with Twitter. If you just type in WEDO and follow them on Lego Education and other teachers or educators or schools that have WEDO at their school, you'll learn a lot and get a lot of inspiration ideas. And like here's some Halloween challenges that people have done recently. Then funding ideas. I've been more successful with local funding, but through Lego Education on their website, they do have some ideas to use, like Donors Choose. And if you've ever done donorschoose.org, you can fund your classroom materials through community donations. You can do grant writing, which is what I did for a local group. Then you can also, here's other types of funding, like using your Title I funding, if you put it into your school improvement plan. But I would seek your principal for those kinds of ideas and seek your school improvement team. Then also YouTube inspiration. This link here from my slides will take you to some different WEDO videos that have some great inspiration. And then I've attached 2 videos here that you can check out. Then we have this is the lesson plans. So the lesson plans can be accessed through the app on the iPad or on the Chromebook, but teachers, you can go and start your lesson planning by going to education.lego.com /en-us/lessons, and if you just go to Lego Education and search WEDO lesson plans, you'll see all the unit plans. The cooling fan is more of an introductory, so it's great to do that in first and second. I've even used it as young as kindergarten, but you also have like the, there's one that's like a robot that is supposed to let you know when, like a motion robot. It kind of introduces them to all the pieces in a kit. So this is the smart hub, and you have a motor, are really the only 2 pieces in the lower base, and then you have these other Lego elements that are added. They have the plant and pollinators. You have your predator and prey, frog metamorphosis, robust structures. I love Milo. So once they understand Milo, they can, take Milo and design their own rover. And a rover could be used anywhere. And it talks about how scientists and engineers use rovers to explore remote places in the world. And so, you use that vocabulary remote and explain through context clues that remote means a place that's hard to get to, not like your remote control. And students look at a video, an introductory video that shows drones being used in remote places in the world, and submarines, because these are hard to reach places. And so scientists and engineers and NASA, they all use rovers all over. There's even a moon rover, that a lunar rover that's used. This is the moon base. This is inspection, speed, sort to recycle, pulling. This is adding another like sensor. There's a motion sensor you could add to Milo. Where it explores, you just click load more, and it will load even more lessons. If kids, if you have extra time at the end of a lesson, students can work together with another team to try to get the Milos to collaborate and work together. Then there's the tilt sensor, city safety. Then you get into computational thinking lessons that are in there as well. The animal senses, sending messages, emotional design, preventing flooding. We used this one as one of our STEM stations when we did the hurricane STEM stations, and talked about different landforms. And then with all the flooding we had in North Carolina, volcano alert. We did this with current events and used the one of our students in the class. Her father was deployed somewhere where they had a volcano at the time. Drop and rescue. We actually tied this into different stories where animals and people have been rescued, or materials, supplies were dropped in to help rescue by designing a helicopter. Extreme habitats, space exploration, animal expression, and then just keep loading more. We're at 24, 25. Hazard alarm. Let's see, I think we already did some of these. Wildlife crossing, the spy bot. This is one of the introductory ones, easy to do with kindergarten through second grade introduction. But even on up, it's a great introduction to the kit. Moving satellite, definitely ties in with space. Glowing snails and the grabbing objects. I showed the students an app where you can actually monitor satellites all around the world, and it tells who owns the satellites. That was really cool. So let's go back to our slides. This is some paper that I've used with my engineering lessons. So it goes through the engineering cycle of ask, imagine. So you ask, what do you need to know to get started? Well, sometimes kids don't have a lot of prior knowledge, but KWL chart is always great. And then helping them once they have asked the question, done some exploration, maybe bring in some VR headsets. They can imagine how they're going to solve this challenge. And when I tell them to close their eyes and make a movie or a picture in your mind what it's going to look like, then share that out and communicate with a group. Then as a group, each person, I make every person, if we don't, or have a person for each one that's going to do, each team that will be drawing the blueprint. And what materials, make a list of the materials that they will need. You can always add a budget piece and have students have a certain amount of money they can spend and give the Legos a value, you know, and then they have that whole economics piece that ties into it with math. You can build, then they're going to build their design once they have their blueprint. I monitor as a coach and really home in on asking the students to reflect on, are you following the plan? Because that's important to follow the plan to fidelity, and then they can reflect and ask themselves, you know, was your build successful? Yes or no? What worked well? Because we can always learn from everything. And you can give examples of engineers that had lots of failure. Elon Musk, you know, blew up, you know, 3 rockets. On his 4th rocket, he was about broke before he was successful with the rocket that he sold to NASA through SpaceX. And you know, the Wright brothers and the failure they had with flying planes. What would you change if you could do this again? So thinking about what they can learn from their failure, or even if it worked, still, we can always make it better. What are some improvements you can make? And then sometimes improvements don't always work. Sometimes we improve things and things get worse. I tell the students, I call that a recall. So here's an example of, you know, starting with asking the question. And these are the FLL Junior books that they are using here. And so on this one, you know, we're talking about what it would be like to live on the moon. You're imagining is the year 2050, you're landing on the moon. What do you know about the moon? So this is what they already knew, that it gets light from the sun, that there's low gravity, that there's no oxygen, no air, no atmosphere. You can float on the moon. Rocks are on the moon. You create craters are on the moon. And then what they wanted to know about the moon. Well, how will I breathe there? And how do you talk there? How do you eat? You know, what happens with low gravity? How long does it take to get to the moon? How long would it take to build a moon base on the moon? So these are things they're thinking about, and then what they've learned. We didn't get to that last, I didn't get the picture for what they've learned, but we definitely went back there. And at the end of each session with FLL, they always go back to what's called a show me poster. That's not a show me poster, but I'll show you in a little bit. But this is how you would ask and get them thinking, get those wheels turning. We even brought in for this one VR headsets for them to look at the moon, and it was a virtual reality moon experience. Imagine. So you show them the materials and have them imagine. This is the Inspire set for the Mission Moon Challenge, and they have to, a part of the group is building a moon base. The other part is actually designing something with the WEDO kits that some sort of has a mechanism. And then so you have the 2 kits that they're using. So once they have imagined and they've asked and imagined, then you're going to plan, and you can see their plans. They draw it into their science, journals, they label it, and then they're going and sharing their plans with each other. And you can see them using some of the Legos to plan it out, and then they start creating once they come up with a plan. And then they improve. This is a student who designed the fan build. And once he did his fan build, they came up with ways to improving it, and they shared it out in Seesaw. This is LJ. Okay, so he said their fan, they put wheels on it, so it could drive all over the science lab to give air. So the challenge in this was Max and Mia are hot in the science lab, and they need to cool it down. And he said by adding wheels to their fan, the air could circulate all over the room, and they could all experience it. These are bulletin boards that I have up in the project room. One with the engineering cycle with questions for them to think about, and then share, you know, it's great for them to share out their thoughts and ideas. And then this is the first core values for First Lego League. You have, so anytime a student is not following the first core values, we go back to the board and we reflect and ask ourselves one of these talking bubbles. You ask yourself what it's telling us to do. If we're not having fun, then we go back and look at why we're not having fun. What do we need to do to have fun during first Lego League? Teamwork. If a team isn't working together, let's reflect why we're not working together. So bring the whole team up and talk about it. Are we being innovators? Are we discovering? Are we showing impact? What are the things that, do you need help and motivation? And then the other most important thing that I have learned from First Lego League, that I have used this in every Lego building with a team has been, or with a group, as a group project, is to assign these roles. And you have navigator, finder, builder, and checker. So the navigator is the person that announces the steps to go through to building the instructions, etc. And then the finder finds the Legos that the navigator tells them to find. And so they find that Lego element or materials. The builder adds elements to the model and they follow the steps the navigator gives them, and they've used the pieces that the finder gives them. And the checker, to me, has the hardest job. And I tell the students, this is the most important job. They're, the main facilitator. They're checking to make sure that the elements have been placed correctly. And I also tell the checker that they're responsible for making sure the navigator is giving clear instructions to the finder, and that the finder is finding the right Legos that the navigator for the navigator, and that the builder builds it in the places the navigator tells them to build it, and that the builder uses the Lego pieces that the finder finds. So it's kind of keeping everybody in check, and it's the checker's responsibility to come tell the coaches like me when a team is not doing their job. So this is the engineering process that we reflect on, and I had a board that had similar things that we just went over. And this is the moon base. So this first thing they had to do was a guided build on the rocket. Then they had to add the WEDO mechanism to push the things out of the rocket that they added. And we'll go over that a little bit more. But this was showing how they used the smart hub. And you can see they used the motor to create a police system here. And then this is a moon base where it looks like this is probably either water or oxygen. I would say water to grow plants on the moon. And they always reflect back on the Show Me poster. This is the Show Me poster where they add pictures and words to reflect on what they've learned from today's lesson as a team. So this is not First Lego League. This is just Forces in Motion. I did this with 3rd grade and a very similar lesson, but a little more rigorous with 5th grade. The second law states that the acceleration of an object is dependent upon 2 variables, the net force acting upon the object and the mass of the object. So this is the science standards for this lesson. And these were I can statements. So from this lesson, I can make observations and measurements of an object's motion to provide evidence that a pattern can be used to predict future motion. I can engineer and program a fast Lego car. So this is one of the guided lessons that are in the kit and you can go on to the app and find it in the books. Teachers, you can go on to Lego Education's website and you can access this lesson. I added this YouTube video for the students to watch just to kind of activate their prior knowledge, get their, the ask part. So that it went over just innovative history about inventors of cars and how, all cars have been improved over time. A lot of people think, Henry Ford invented the first car, but he did not. He's not the inventor of the automobile. He's the inventor of the first affordable automobile. So it just went over the history of the automobile. You can watch it on your own, but you can just see how transportation has evolved over time. And so after they has an investigation and looking at how they won races with the car, and he broke records and started the Ford Motor Company. Stop this. There's also videos built within the app for the kids to watch. This is one, it's a wordless, all the little WeDo people with Max and Mia, really speak, but it shows them following, doing the ask. They are doing research, gathering information like a scientist would. And then after they gather their information and do some research, they get started making a plan. And again, they go through the first cars, how cars improved. I like how they're thinking, Shows motors racing. So hopefully after watching that video, it gets the students really asking questions and thinking about and imagining what this car is going to look like. There is guided steps to build this car, step-by-step instructions, just like you, and you just slide through the page, just like when you buy a Lego kit from the store. But this is a YouTube video where they've put the steps into action. You can see they create a car with a pulley system. But I ask the kids, even if they need to use the guided model, how could you make your car faster? Are there other ways you could improve your car? And so this gets the kids thinking and imagining, but they have to come up with a plan for their own car. So they investigate more speed factors. So with the same race car model and the same setup, students can hypothesize and test other factors that may influence the speed of the car. They can change the motor power. They can, within the coding, they can change the speed. Changing the motor power level from numbers 10 to number 5 will make the car take more time to travel the same distance. Then another thing they could do, second thing, would be to change the drive mechanism pulley configuration. Changing the drive mechanism from a normal position to the reduced speed position will make the race car take more time to travel the same distance. Then continue to investigate more speed factors. They can investigate another element, maybe have students to do the test based on another factor they think could influence the speed of the race car, maybe the width, the length, the height, the weight, or another factor. So some of my students built like a 2-wheel car, some did a 3-wheel car, some did a 4-wheel car. So all those things, and there are different size wheels you can use. I had students who put in a gear system and tried that one as well. Documentation, I talked about in the top, in the tools is a documentation tool. There's a camera to take pictures, and then there's video. Have students document their project in a range of ways. Suggestions may include ask them to take a screen capture of their results. Get them to compare these images with real life images. Invite students to record a video of themselves describing their project to the class. Students may collect data in charts in a chart format or on a spreadsheet. Students may graph the results of their tests, and then they can share those out in Google Classroom or in Seesaw. This is the that we just left. That was a real world science challenge, but this is how First Lego League incorporates real world science. You saw earlier the moon mission, so this is the engineering notebook. If you click on the little book on the slide, it will take you to the engineering notebook itself. I found these online. I think it says up here that it's Junior First Lego League in India.org is who has downloaded this. I did not do this. So you see the First Lego League book, and there's a table of contents, and it goes through each session. So the first session is naming your team. The second session is, the rocket ship to the moon, and start thinking about, you imagine you're in the year 2050 and you're going to the moon, and what are you going to need to get there? And they come with these containers, and they brainstorm what would be in the containers. If you need to solve your problem of air, what would be in there to help you get air on the moon? What would be in the containers in your rocket to help you get water? And then energy, And then the other one, the fourth container, is other things you might want or need on the moon to survive. And then be an engineer, and they start the engineering process, designing. And then they solve the problem of water for one session. They solve the problem of energy, air, and then other problems they might run into. They, get really work more on the moon base and creating the final moon base with everything they need. And then they finalize their show me poster. Then they share their whole moon base and one of the mechanisms they designed that helped them. Their most successful one with the group. And you can see scrolling through the vocabulary, the planning books. So some of my students just planned on paper. We didn't write in the books itself so we could use them again. But it definitely gives them a lot of facts. I like the did you know stuff about the craters, and talks about how the ice is in the craters of the moon and how would you extract the ice to get water. Very engaging. And then this is the team guide. The team guide, if you click on the book, it looks a lot like the student engineering notebook, but it does have little numbers to help you with facts and just some little tips to help. But this was in the 2018-19 season, was Mission Moon. And then last year they changed it. Every year's a different theme. It's the Boomtown Build last year. And so we did the Boomtown Build, and the problem to solve was accessibility. So we talked about people with special needs, and my father actually is handicapped from polio. And so a lot of buildings are not accessible to him, and I gave real world experiences of that. But we talked about other handicaps, people who can't hear, and how would you make a building accessible who have hearing loss, or if people who are blind, what would you do to help with accessibility for those types of things as well. So the students really problem solved and brainstormed the ways to make a building accessible, and thought about buildings in their own lives and community. Then they talked about environmentally friendly buildings that would help make help the environment. Durability, we talked about weather patterns around the world, and you could test them, the durability of structures, whether there were earthquakes or tsunamis and hurricanes and flooding, and just the different types of ground and soil. And we looked through VR headsets, and we had another diff come in, Sarah Eiler came in, and she actually did a whole tour, virtual tour with the students on different structures around the world. And so we talked about durability. After those things, then they got to just explore other structures. This was more things that are aesthetically pleasing and things that they liked about structures, very artistic, the lines, the patterns, all those things, the different materials that buildings are made out of. And this is the team guide to help go along with. And each one of these, again, I think the First Lego League of India has is who created these. Let's see, it's loading now. This one says gammacode.com Lego League Junior. I didn't create these. These got downloaded by someone else, and I found them online. But it looks very similar to the sessions from the Mission Moon. It's just instead of space exploration and aviation, we are doing you're doing more architecture design of buildings. And we actually did architecture for STEM camp one year, and that was the kids had to design a school and playground, and they designed playground equipment for our school. This is the end of the season. We did green screen interviews. So if you go to bit.ly/bullsbuild, it will take you to the YouTube video. Do that. Sorry, or you'll click on if you click on the YouTube video in the slide, it should play as well. But the students, they chose the background for their green screen. They chose from cities that they were participating in. And then they put their show me poster on the front of their table. But they each took different parts. They told the name of their team, and they had to explain how they addressed all of the issues that they had to face. So they had to talk about their durability, whether it was economically, they talk about how it was durable, how it was let me go back to I can't remember now. Hold on. They talk about the accessibility, the environmentally friendliness, the durability, and any other structures. And then, so they chose different places in the world that they would like to explore, and their structure went with that city. So I hope you'll check that out. I want to give credit to LEGO Education, also to this, these teachers from Charlotte Mecklenburg School. I asked permission to use some of their LEGO slides because I attended one of their WEDO sessions once, and they had some great slides that I wanted to include in my slides today. I want to thank you for attending my session. If you go to my slides, which is bit.ly real stem diff. So that is how you get to my slides, bit.ly/real stem diff. And then you can click the bit.ly to evaluate our session today, and that's how you'll get your CEUs. If you want to find me, you can find me on Twitter. I am at Jill_Tyler8. Or you can email me at jsnutherly@ncmcs.org. Thank you again for attending our building engineer session. And if you ever need anything with Legos, I would love to help you. Thank you.